So welcome to another video of A-Level-Up Maths. So basically what we're going to be doing in this one is having a look at some equations with logs in, covering a few of the basic rules, having a look at a few examples, and just taking you through the main points that you will need. So the first thing to know is about inverse operations. So we know that if we have a log to the base 5 of x equals 2, the opposite of a log to the base 5, which is really this bit that I've just underlined in green, is a 5 to the power of. So when we effectively apply this inverse operation over here, we will get a 5 to the power of 2, and there we can easily see that x is 25. So this is one way around of thinking about it. Now the other way around of thinking about it is if I have something like 17 equals 4 to the power of x. Now we can see that 4 to the power of 2 is 16. It's not quite 17, so we know it's going to be slightly more. X is going to be slightly more than 2. But how can we actually, rather than just estimate it, how can we do it? Well, the opposite of a 4 to the power of, this bit here, an opposite of 4 to the power of, is a log to the base of 4 of 17 equals x. And if you place that into a calculator, you will get x equaling 2 point, etc. So they are the two main rules you need to have a look at. So let's have a quick look at, have a go at this particular example here using those two theories. Just to show you, it's going to be 4 to the power of is going to be opposite of your log base 4, and you've got a few other steps to apply. So pause the video and have a go at this top one here. Okay, so let's move on to another example. Okay, so we are going to solve this to 3 decimal places. So let's have a look at the steps. Well, for this one, we're going to have to use a couple of log rules that you've seen in the previous video. What we need to do on the left is we can apply the power rule, which the n log x power rule. So that 2 is now x squared. Here we've got 2 logs adding, so we can apply the multiplication rule. So in the brackets we are going to have 2 this multiplied by 5. So just simplifying that on the right, we have log to the base 6 of 10x minus 25, just multiplying out the brackets there, 5 times 2x, 10x, etc. And now what we're left with is the log to the base 6 of x is a log to the base 6 of this other thing. Now, in that case, because you've only got one log base 6 on both sides, you can remove those two, and you can be left with this equation with no logs. You can only do it once you've got one log on the left-hand side, one log on the right-hand side, and then you can kind of inverse of them. Actually, what you're doing is you're doing a 6 to the power of on both sides. And now what kind of equation do we have? A quadratic. So we must set this equal to 0. We can then factorize this, as it does factorize, to x minus 5. X minus 5 equals 0, which means we only have one answer of x equals 5, and that's our final answer. Now, it is really important to check that this answer actually works in our original equation, because actually negative, I'm going to write this down, check it works, because negative values for logs do not work. Okay, so just to show you, just to give an example of that, if you've got log to the base of, anything 3 of -2, this is going to give you an error. So always check things work and they don't cause these errors through negatives. This one does work, so it's all good. Okay, we've got to use a substitution. We can rewrite this equation as u squared minus 5 times u plus 4 equals 0. And this makes it far easier to solve because it makes it, you're just then solving a quadratic, which we did in the example above. And you can see this turns out to u equals 1 and u equals 4. Now, of course, we can't stop at this stage because we've only got u equals. And clearly, we need to solve for x, which is the value in this equation. So we need to bring back the substitution. And so we need to say, well, if u equals 1 and u equals 3 to the power of x, then 1 equals 3 to the power of x. And this we can only solve, well, in fact, this one we can kind of solve various trial and error. If you remember lots of your indices rules, you will know that 3 to the power of 0 equals 1, and so x is equal to 0. Okay? You may not have to just remember that. There may be another way. Let's have a look at this. If we have 4 equals 3 to the power of x, similar on this side, how are we going to solve this one? Well, we're going to solve it in exactly the same way as we dealt with this initial one all the way up here, okay? And so what we do is the opposite of 3 to the power of is a log to the base 3 of 4 equals x. And by typing this one into a calculator, let me just... Okay, so I thought this would be a perfect time to show you how to use the calculator. Right, so all we need to do is just turn it on. This is a Casio calculator that will work in a similar way. Now we notice that we've got one log button here and a log base button here. Now your calculator, most modern calculators will have both of these buttons. So if it doesn't, there is another method. I'm not going to go into detail right now, but of course on this one we want to use this log to the base 3 of 4 is what we needed, and we needed that to 2 decimal places. It's 1.26. So coming back to the video, we just said to 2 decimal places, this is 1.26. So you can see that there are two answers to this equation B here. It's 0 and 1.26 to 2 decimal places. Have a go at A and C using a similar method with this substitution, and good luck to you on those. So finally, in exams, you may get given something more complicated like these two examples at the top here. Now, I'm not going to do one of these. I'm just going to start you off to show you a few of the tips and tricks that we'll use. So in this one, you can see we have a 25 and a 5. There are two different powers. To eliminate that, all we need to do is turn 25 into 5 to the power of 2 and effectively rewrite all of the rest here. We also need to know that 5 to the power of t plus 1 is 5 times by 5 to the power of t, because we are adding powers, and this is what should be our initial equation, and you can follow the technique above to complete this. Over here on the right hand side, we should know that 3 to the power of 1 times 3 to the power of 2x would be this bit here. Our 15 is obviously 15, and our 2 times 3 squared times 3 to the power of x would be there. And I think what you can do is try to tie that up and apply the above method to complete these two harder ones. I would say that these two are both extension questions, but could be seen on the new syllabus. Anyway, I hope you've enjoyed another video from A-Level-Up Maths. Like, comment and subscribe to the channel because we're going to be posting a lot more videos. In fact,